Assalamualaikum and hi. My name is Muhammad Nizar bin Abdul Halim and my matric number is 207508. Today we will present about our PBL and we are from group 2. So I will conduct the activity 1, which is operational amplifier basic, and the activity is to complete the crossword puzzle below. We can see here there are 8 words need to be find out, and we are already given 8 hints to find the answer. First, we will settle the across words first. So first we have number 3. Number 3, we have already given the hint, which is the theoretical value of open loop gain. So we look into number 3. We have 8 letters to be filled. So we already decide and we think the answer is infinite, which INFINITE. Next, number 5. The hint is number of the output terminal. We find number 5 and we see that there are only 3 letters need to be filled, and our answer is 1, ONE. Next, number 7. The hint given is the shape of the operational amplifier symbol. Our answer is triangle, TRIANGLE. Next, the last words for across words is number 8. The hint is another name for operational amplifier. So our answer is Opamp, OPAMP. Next, we will settle the downward words. First, number 1, the hint given is the ratio between output over the input voltage. We find number 1 and there is 4 letters need to be filled, and we think that the answer is gain, GAIN. Next, number 2. Number 2, we already given the hint, which is name of the negative terminal. There are 8 letters need to be filled, and we think the words suit to the hint is inverting, INVERTING. Next, number 4. The hint given is number on the input terminal. We find number 4 and only 3 letters need to be filled, and our answer is 2, TWO. Last one, the hint for number 6 is the connection between the output back to the input. Number 6, we think the answer is feedback, FEEDBACK. So that's all from me. Thank you.
Good day, everyone. My name is Pragaladan, son of Balamurugan, with the metric number 205698. And for our PBL session, I'm going to discuss with you all the questions in activity 2, which is operational amplifier configuration. Well, for the first part of the activity 2, we are going to complete the table below by giving the operational amplifier name and the output formula for each and every configuration. Well, if we take a look at the first diagram in the table, there are so many input voltages that is connected to the inverting terminal of the amplifier. So based on the diagram, we can conclude that the name of the operational amplifier is the summing operational amplifier, because based on the definition of summing operational amplifier, it is a circuit configuration that is used to sum up the multiple input voltages that is present into a single output voltage. And next, based on the diagram, the output formula will be V out is equals to negative RF in bracket V1 over R1 plus V2 over R2 plus V3 over R3. And if we take a look at the second configuration, the input voltage signal is directly applied to the non-inverting input of the amplifier. So from the diagram, we can conclude that the name of the operational amplifier is the non-inverting operational amplifier, and the output formula will be V out is equals to, in bracket, 1 plus Rf over Rin multiplied by Vin. Next, if we take a look at the third diagram in the table, we can obviously find out that the name of the operational amplifier is the differential operational amplifier. For the information, a standard operational amplifier has two inputs, which are the inverting, the negative side, and the non-inverting, the positive side, respectively. We can actually connect the signals to both the inputs, which will result the differential operational amplifier, as in the diagram above. Basically, the output voltage will be proportional to the differences between the input voltages. So, based on the diagram, the output formula will be V out is equals to Rf over Rin bracket V2 minus V1. Next, if we take a look at the fourth diagram in the table, the voltage input signal is directly applied to the inverting input of the amplifier. So, we can conclude that the name of the operational amplifier is the inverting operational amplifier. And the output formula for this type of amplifier is V out is equals to negative Rf in bracket Vin over Rin. And finally, if we take a look at the fifth diagram, we could obviously know that the name of the operational amplifier is voltage follower. This is because the output is connected directly back to the inverting input. And for the voltage follower, the V in is exactly equals to V out. Now, we are moving to the second part of our activity 2. And the first question is, calculate the output voltage of an OP-AMP summing amplifier for the following sets of voltages and resistors. Use Rf is equals to 1 million in all cases. And the all values of the V1, V2, V3, R1, R2 and R3 are given for this following question. If we refer back to the question, it is clearly mentioned that this is a summing amplifier. And we have gone through about all the types of operational amplifier and its respective output formula. And based on the diagram, there are three input voltages that is connected to the inverting input. So we can deduce the formula for this summing amplifier as V out is equals to negative Rf in bracket V1 over R1 plus V2 over R2 plus V3 over R3. And by substituting all the respective given values into this formula, we could find out that the V out is equals to negative 7 volts. Next, we have moved to the final part of our activity 2, and the question is, what should be the input if the output required from the configuration is 15 volt? This question is not same as the previous one. This is because in the previous question, The name of the operational amplifier is clearly mentioned in the question itself, and that makes us easier to find out its output formula. So, for this type of question, we have to examine the diagram very clearly. And based on the diagram, if we take a look, that we could find out the input voltage signal is directly applied to the inverting input of the amplifier. So from the diagram, we can deduce that this is a inverting operational amplifier. And the formula for the inverting operational amplifier goes like this, which is V out over V in is equals to negative in bracket RF over R in. So the value of V out, RF and also R in are given in the question. So by substituting the given values into the formula, we could find out that the V input is equals to negative 1.5 volt. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nafisatul Karatayun binti Azman with metric number 205795, and today I will be explaining on activity 3. So the first question is calculate the output voltage if V1 equals to V2 equals to 700 millivolt. So firstly, we must identify the types of amplifier for each question. So for the first question, we have the first one, which is the first amplifier, which is the inverting amplifier. So in inverting amplifier, the formula that we must use is V output over V input equals to negative RF over R1. So from this picture, we already given the RF, which is 500 kilo ohm. So we can just substitute the RF, and then we also have the R1, which is 250 kilo ohm. Just substitute into the R1 here. And then V input, as mentioned before, we already know that V input, which is V1, equals to 700 millivolt. So we can just substitute inside this formula, inside here, V in for the V in. Omit the milli, so we need to time 700 with 10 to the power of negative 3, then we can finally get the voltage output for the first amplifier, which is negative 1.4 volt. Negative 1.4 volt is the output voltage for the first amplifier, which is the inverting amplifier, but this is not the total output voltage yet, because we have another part, which is the second amplifier. So for the second amplifier, this is different from the previous one because this is summing amplifier. In summing amplifier, we'll have more than one input. So we already know that just now we found out the voltage output for the inverting amplifier, which is the first amplifier, equals to negative 1.4, which is actually the input for the summing amplifier. So now we have two input. For summing amplifier, we will use the formula, which is V naught equals to negative RF in bracket V1 over R1 plus V2 over R2. So we already know that V1 here, which is the voltage input for summing amplifier, the first one is negative 1.4 volt, and the second input voltage, which is V2, equals to 700 millivolt. So we can just substitute inside the formula. So RF for this second amplifier, which is summing amplifier, is 500 kilo ohm. So we can just substitute 500 into this here. And then we have V1. V1 is the voltage, the first input voltage in the summing amplifier, which is negative 1.4 volt. Substitute and put it here. And then we have R1. R1 is for the first input, which is 100 kilo ohm. So for V2, V2 is the second input voltage for summing amplifier, which is 700 millivolt. So we must omit the milli, so times 700 with 10 to the power of negative 3. And then for R2, the resistor is 50 kilo ohm. So just by calculating it, we will find out that the total output voltage is 0. This means that for this whole configuration of amplifier, there is no output voltage because voltage output is equals to 0. So for the second question is we must calculate the input voltage if the final output is 10.08 volt. So for this question, like the previous one, we must identify the types of amplifiers so that we can use the right formula in order to find the answer. So we can start with the third amplifier here. For the third amplifier, this is the inverting amplifier. So the formula that we must use for inverting amplifier is V output over V in equals to negative RF. So since this is for the third amplifier, so RF3 over with R3. So we already know that we're given that the voltage output is 10.08 volt. So we can just substitute inside this formula. And RF3 for the third amplifier is 100 kilo ohm and the R3 is 5 kilo ohm. So by substituting all the information that we have, we'll find out that the V input is negative 0.504 volt. This is the voltage input for the inverting amplifier, for the third amplifier, which is inverting amplifier. This voltage input is also equals to the voltage output for the second amplifier, which is V output 2. So by this information, we can find out the next voltage input for the second amplifier by using the information that we find out just now. So for the inverting amplifier, we still use for the second amplifier, which is also the inverting amplifier, we still use the same formula, which is V output. Since this is for the second amplifier, so it's V output 2 over with V input equals to negative RF2 over R2. So we already know that just now we found out that the V input for the third amplifier is actually the V output for the second amplifier. So we can just substitute V output for the second amplifier is equals to negative 0.504 over V in is the one that we want to find out equals to the RF2. RF2 here for the second amplifier is 5 kilo ohm over with the R2. R2 is 5 kilo ohm. Then we can find that V input is 0.504 volt. This V input is the V input for the second amplifier. Like what we did to the amplifier, it means that this voltage input for the second amplifier is also equals to the voltage output for the first amplifier. So by using the answer that we got just now, we can finally find the total input voltage. For the first amplifier, this is a non-inverting amplifier. So the formula will be different than the other two. So the formula that we must use is V output. Since this is for the first amplifier, so it's V output 1 over V input equals to 1 plus RF over R1. So what I mentioned just now is that the voltage input for the second amplifier is equals to the voltage output for the first amplifier, which is the non-inverting amplifier. So you can just substitute the V output 1 that we just calculated just now, which is 0.504 volt over V in equals to 1 plus RF. RF for the first amplifier is 10 kilo ohm over R1. R1 for the first amplifier is 5 kilo ohm. So just substitute 5K. And then we will find out that the voltage input is equals to 0.168 volt. This is the total input voltage for this whole configuration of amplifier. So for the third question, we must calculate the output for this whole configuration. We're already given in this picture, we already know that V1 is equals to 0.1 volt. So first, identify how many amplifier that we have. We have 3 types of amplifier in this question. This is the first one, this is the second one, and this is the third one. So let's focus first on the first one. The first one here, this is a non-inverting amplifier. So the formula that we must use is, since this is the first amplifier, so it's V output 1 over V input 1 equals to 1 plus RF over R1. So we can just substitute. We want to find the output for the first amplifier. So we can just substitute. We already know that V input is equals to 0.1 volt. So just put here, and then equals to 1 plus RF. RF is already given, which is 400 kilo ohm. And then over with R1, for the first amplifier is 20 kilo ohm. And then by calculating all of this, we'll find out that V output for the first amplifier is 2.1 volt. So we're already done with the first amplifier. So now we move on to the second amplifier. The second amplifier is known as buffer amplifier. This is negative. Okay. For buffer amplifier has been explained by Piraga, V output is equals to V input. So for this amplifier, we must consider the V output. If we want to find the V output, we'll just conclude it as the same with the V input. So we're already given that V input is 0.1 volt. So 0.1 volt is actually the voltage output for the second amplifier, which is V output 2. So V output 2 is equals to the V input, which is 0.1 volt. So now we already know that the voltage output for the first amplifier is 2.1 volt, and the output voltage for the second amplifier is 0.1 volt. So now we can proceed to the third amplifier, which is the type of amplifier is summing amplifier. So now that we already find the output voltage for the first amplifier and the second amplifier, we know that those two outputs are actually the input for the summing amplifier. So we consider for this the third part of amplifier, V output for the first amplifier is the V input, the first input voltage for in summing amplifier. And just now the V output for the second amplifier is actually the second input voltage in summing amplifier. So in summing amplifier, we must use the formula V output equals to negative RF in bracket V1 over R1 plus V2 over R2. So now we know that RF in this summing amplifier is 100 kilo ohm. So we can just substitute 100 kilo ohm. And then V1 is the first input voltage in summing amplifier, which is what we just find out just now, which is 2.1 volt. So just substitute 2.1 over with R1. For the first input, we have 20 kilo as the R1. So put it in here. And then we have V2, which is the second input voltage in summing amplifier, which is also the second output voltage in second amplifier. So what we found out just now is 0.1 volt. So we can just substitute 0.1 over with R2. R2 is 10 kilo ohm. So we can just substitute by substituting every calculation. We'll find out that the voltage output is negative 11.5 volt. This is the total output voltage for this whole configuration. So that is all from me. Thank you.